Hello everyone. Last video we solved the lab of chapter 1 using Jupyter and I used my own machine. But today I'm going to solve the labs from chapter 2 using the Raspberry Pi. And the Raspberry Pi is now plugged in and is connecting to the internet as well. And as you can see, I launched the application Cisco PL app that we talked about last week. And now I can press connect here to connect to the Raspberry Pi, and now it's asking me to enter a password that I already set on the Raspberry Pi and then click login. Here we have the content of the Raspberry Pi for the the course, and here we have course materials, and here we have my files. However, we go to course materials and then we have big data and analytics. This is the course that we are now working on. There are other materials, for example connecting things, that this is a course should be done before this one. The labs of this course, the packet tracer labs, had been solved and are in the channel using IoT, like the name of the channel, the playlist is IoT, and now we are trying to finish this one. So here, this is the lab we solved last week. It was take a Python challenge, and today we are going to check or to see the labs from chapter 2. By the way, here in the Raspberry Pi, the modules, the packages, the files are all available here, so you don't need to do anything like external. You don't need to import. Even you can, but you don't need, because all the materials, the files are available here. However, I will also upload the files on Canvas, so you also can use them. If you don't have a Raspberry Pi or you don't need to use a Raspberry Pi, you can download the files and you use Linux to solve or to proceed with solving or with the solutions of the lab. Okay, so let's start with the first lab here, which is 2.2.4.5. So let's get started with the first lab. And in this lab we are going to learn how to read the data, analyze, and of course before analyzing the data we have to prepare the data. And the last part is to visualize the data. Okay, so first part we import the modules. We know NumPy, we know pandas, we know also matplot. Now NumPy is to do numerical operations, for pandas to deal with the data frames, and matplot is to generate figures, and volume, it's a new module here. We did not cover it in the classes before, but we are going to learn about it. Actually, this module is used to generate a figure on a map. Okay, so there will be no new ideas or something like that. We only need to learn how to use it, and we will see this. So first we import the modules. The first one, NumPy as MP, pandas and PD, and the matplot as PLT. These are aliasing, and import the volume, everything from this module. And here, if you see something like this, it means that we are going to see the figures inside the page itself. So we don't create a new window to generate the figures. So we can do this by put the percentage at the beginning of matplotlib and here inline. Alright, so first thing we need to do this with first thing we need to do is to load the data. And the data actually is in a file called map crime incidents previous 3 months.csv. This is the type of the data, and it is in this direction, directory. So we can check it. So if we go to the data, and then this is the file that we are going to use with it, which is actually under the same directory, and then we have data, and then it's going to be this way to import the path. Okay, we put the path in a variable and then we use pandas to read the data. And when we use pandas to read the data, we are calling now this one is a data frame. Alright, now let's try to run this one, and here we have an error. The error says that PD is not defined, this one here. This is correct because we did not import yet the modules. We wrote them, but we did not execute this cell. So first we need to run this one. Now Python imported everything like these modules, and now we can run this one, this cell one more time, and now we have no error or errors, and everything went fine. Alright, now to make sure that the data is imported to the system, we can use a Linux command which is called head here to list the 5 first lines from this data frame file. So when we start in Jupyter with the exclamation mark, that we are instructing the Python or instructing Jupyter to run this command as a Linux. Alright, so for example, I can simply use here exclamation mark ls. Now you know this command in Linux. This is highlighted or commented out, and now I have ls, the command implemented in the system. Alright, but now just can use head or less or tail as you want. Okay, so when I run here, I have the data displayed here, but it's not a good practice to do this because actually it's not clear. So to do this, we can simply use the PD or pandas to set option. Now we are going to see the 10 rows from the data frame. So if we run this one here, and you can see now I have 10 rows, or actually I have here the visualize 10 rows, but then I print the SF, which is I already imported here. So the data frame actually now available using the SF object. Okay, so now the pandas displayed the data frame. It has 30,760 rows and 12 columns. So the columns are here. So here we have the columns, and here then we have the rows. Okay, let's assume that we only need the columns. We don't need to the rows. So in this way we can use the sf.columns, and here we have the columns. The first column is incident number, category, description, day of week, date, time, PD, district, resolution, address, XY, and location. And then the type of this is object. This is not an inside the list. So here we have the columns. So if we count the columns, we have 12 columns here. So here is a question: how many variables are contained in the SF data frame? Ignore the index. So here we have 12. Then we have used the length function to determine the length of this data set or data frame. We already saw this here, which was 30,000 something. But to see it again, we can use the length function again. So this is the length of or how many rows in this data frame. Alright, the next part, which is about preparing the data. We already also explained this, that preparing the data before analyzing it or generate figures on it is a crucial step that we should make sure that the data is ready. So here what we need, actually we are going to add or to make it more obvious by having the date and the month of in a separate columns. Alright, so let's add a new cell here, and now let's print SF, which is the data frame that we have. And as you can see here, the first one we have incident number, and this one is not needed. Actually, we cannot draw anything about this because we don't have information on this, so we don't need this column here. We have to drop it. We also, in this task, says that the location also is not needed. We have to drop it from the data frame. What also we have to notice there, that we have the date. In the date we have here the month and the day. And now we are going also, after that we are going to add two columns instead. The first column contains only the month. The second column contains only the day. Okay, so let's see how we are going to do this. The first one is for the like generating a new column. So to this data frame, add a new column, and the content of this column is going to be from the date, which is from this one. Take the first two values, which is here in position 0 and 1. So we are going to use a lambda function, where we know what does lambda function do. Actually, it's a function with no name. That's why they call it lambda, and it's a one-line or inline function. So we don't need to use define function and use the structure that we learned about it. So what this lambda function does here actually is going to take the first from the row. It's going to take the first and the second value. So we know that 0, this is 0, 1, 2. So here we have 0, 1, 2 is out of the range. So the output is going, for example, going to be here only 0, 6. And it's going to return this one here and apply for all the data frame. So for each set, for each column, for each row, we're going to return the value of these only two to a new column called month. The same idea is going to apply for the day, which is here, which is, you can see, it's from position 3 till 5. 5 is out of the range, so the actual value is going to be the third and the fourth one, and apply it for all the data frame and put the output in another column called day. Okay, so let's run this here now, and again let's create another cell below, and now again SF. Let's check it here, and now we should see two new columns. Which one is the month? The second one is the day. Okay, let's move forward, and now let's try to delete the location and the first. Before we move forward to delete, let's just analyze these two cells. Here we are going to print from the month, the column month, the first 5 elements. Let's highlight this, and then here we have from the month the first 5 elements. If I go up, and here you will see the first 5 elements are all 8, 31. So here are 8 for the month. For the first 5 elements from the day, we're going to see also 31. Alright, so now actually it's clear that what it's successfully done, or you already, I recommend you to check the data frame to make sure that you did the code in a correct way. Alright, then what is the object, or what is this the type of this column here? It's actually an integer 60, like the integer value. What about also we can do the day? This is another column, and here we have also an integer. Okay, now let's try to remove the two columns that we talked about. The first one is this one. Okay, let's check it again one more time. Let's add insert cell above, and again SF, and run again. Here we don't need this column, as I mentioned, and we don't need the column called location. We don't need this information from the data frame. So let's learn how to drop them. The first one, we use a function delete. So if I run this one, and then I insert another one below, here as F, now we should not see the incident number anymore. And also we can do the same by use the drop method with the SF drop, and we specify the location. Okay, for axis 1, it means the column. If we put 0, it means a row, and in the place it means that keep the change on the same data frame. So again, we now executed like we dropped actually the location column. If I run and check the cells again, I don't see the location anymore. Instead, I see the month and the day I just added. Alright, now let's start to learn how to analyze the data. So after preparing the data, now we need to analyze the data, right? Okay, so the first one here, let's start to check the column called category. What is about? Insert, and then SF, and then let's run it again, and here we have the category. Then this is the category of the crime. And now we need to check like which one has the like statistics of how many for example drug crime happened. So to do this we can use a value actually a method called value counts, and then we will have statistics about all of them. So what I wanted to explain that in this data frame we have this type of crime happened 8,205, other offenses 4,000, and so on. All right. So what about if we want to order them in from the smallest to the largest? Then we can put the value inside the parentheses to be true, which here we will see from the smallest to the highest. So what type of a crime was commented the most? So the most one, actually now we can see that this one here, which is larceny, theft. Okay, and see by nesting the two functions on the same command, so we can write them together in one line, so we will see the same output as before. Okay, so now we have a challenging question: which PD district had the most incident of reporting crime? Provide the Python command for this. Alright, so again now we have another the question here, we search here based on the category. Now we would like to see this district. Which district had or has the highest reported crime? Okay, again we can check the data frame, which is this one here, and here we have the district. So we take this column and then we specify the value count, and then we put the ascending as true, and here we have this one has the highest amount of data there. I mean the crimes is sorry, this one, Southern 6,000. This is the least, this is the most, or this is the smallest number of crimes is, or here are the highest number. Okay, now let's assume that we need to subset the data into smaller data frames. Okay, now we are going to present the only crimes happened in month 8 or in August. In this way, we actually make a new variable, and then we refer to the month or to the column we want, and then when equals 8, and then we need August. Let's run this one here, and here we can see that it's going to be all in August. Then we filtered the month. Okay, what about so here how many crimes incident were in the month of August? We can find it here. Alright, the second question is actually how many burglaries were reported in the month of August. Okay, so let's return back to the data frame. And as you can see here, we have the category and there are the types of crimes. So now we would like to check here only like how many uh, burglary happened in this category. So here in the first example we search for the month 8. Now we search for any crime started with burglary. Okay, so let's run this one here, and now we see that starting all of them with burglary and all in all data frame. Okay, and this is the first variable in August crime, the second variable in August period, which are actually they are not the same. So we have two variables or two subset of the data frame. The first one for the crimes in August, the second one in like in the burglary. All right. Of course, you can also specify the and, or you can do any logical operation here. So let's say we can search it here about in August. We can specify and as a month in the same line, and then we will have the Bulgari in August, and we have the new data frame. Okay, so again, now as I mentioned, now the example here we can do this also using a method called the query, and now we search for the SF with a month 7 and day 4. So we are going to find like for the column month in July and the 4th day. Like here we can check it time out. Here we have month and day. Okay, now let's start and check again the columns. Here we have the columns as we wanted. So we generate the variables, we did not change the columns. Okay, in the fifth part we are going to present the data. Okay, so to present the data we use the plot method and we specify the column X. So let's check first one more time, then insert above, then we check the x-axis and the y-axis. They are here two columns in the SF. So from to draw them, so SF and the column X and the column Y with like a circular object. So that's why it's arrow here. So when we execute this code, plot show, we mentioned that we need to inline, so the matplotlib to be inline, so we see the output here and they're all in the type of circles. And all right, so next step is going to identify the number of department districts, and then we are going to generate district a dictionary for each like department. This in each district we will have a code for it. Okay, so let's first make it clear with this, and then let's run this one here. So we have here for the only a unique variable here in each the data frame. So the first one is going to be this one, second one, third one, and like and so on. So here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, this is the PD districts. All right, I mean the police department. This is for PD district. So this one here. Okay, so what we need now, we are going to generate a code or a dictionary. So for example, we will specify that PD district, the first one is going with the code 0. This is 1, this is 2, like the dictionary, like it's going to be the last one in the dictionary, that this one with 9. Okay, and then we can do this by generate the dictionary. As you already know, we use the zip function and change it to the dictionary. The key is going to be the PD district, and the code for it is going to be the position or the index of this one. So when we run this one, so here we have the key, and here we have the value. So from 0 to 9 is going to be 0, 1, 2, 3, 4 as already mentioned. Alright, then we have apply the lambda to add the police department integer ID to the new column in the data frame. Okay, so we are going to generate a new column to the data frame called PD district code, and this one is going to use the lambda function to apply to all the data, to all the data frame, and we return the the position of it to the district. So if we run this code here, as we see, we have a new column, and this is the content of the column. Okay, then we use the newly created code to automatically change the color. So here we have the again the X and Y, and now we use PT scatter the position, and then we give a color. So here if you type red, it's going to be in red format. If you type green, we also have it in green, but we need to give a color for it, so we will use this color code here, which is actually in the data frame itself. Let's see what is the problem here. Okay, the problem is that we need to specify that this is a column. Okay, so here we have the color distributed as the code we generated here. Okay, now in the next step we need to add this figure to a map, and to use this, as I mentioned, we are going to use the volume here, and from matplot we are going to import the colors, and then we generate this district, to have it in a district, and then we are going to print a list of each of these colors in a hexadecimal format. As it's mentioned here in step 1, you create a simple plot that displays where crimes incidents took place in SF county, and the plot is useful, but volume provide additional functions that will allow you to overlay this plot over an open street map. Okay, so volume requires the color of the marker to be specified using hexadecimal value. Okay, so to use volume, we need to generate a code through hexadecimal value. And to reach this, we can use the color package, and then we change the value to be in hexadecimal format. Because you cannot use it like this with the volume by like an integer, then we have to have this code here to generate the 9 colors in hexadecimal format, and then we can apply it to and of course we need to generate the dictionary. So now the new dictionary, we have PD, or the police department, with the color encoded in hexadecimal format, and then we need to use the volume. First we define object from the volume, which is map OSM, and here we have a volume.map. We specify the location to draw to generate the figure. Here you can see there is a mean function again here. As you can see here, create the map using the middle coordinates of the SF data to center of the map. To reduce the computation time, plot every is used. Alright, so here all the values is going to be plot every 50, because if you will put it 1, it's going to take a long time. So here, of course, it's not, if you need more precise figure, then you have to reduce this value. But now, for the explanation sake, to keep it the computation time fast, then they used now here 50, and then we have a list which is generates the position X, Y, and the code, and then draw all of them into the map OSM. So if we go from here, we create a circle marker, and here in this position between 0 and -1, plot every. So this is the starting, end, and the range, the value of between them, which is 50, and brought them to the map. And last, we only will check the map, and the map is going to be here, this one. Okay, so this is about the analyzing the data here. We can also zoom. Actually, this is the same figure. We have got it here, but using this one the same, if you notice this, but with this model, the volume, we managed to draw it over a map. Okay, thank you so much, and see you in the next lab.